Hello students, in this video we are going to start with a new chapter, that is the 10th chapter in class 9 physics, that is the work and energy. Okay, so we are going to start this chapter part by part, and today we will be discussing the first part, that is the introduction to the chapter. Okay, so we are going to learn about work and energy in this chapter. So first we need to know about work. Okay, so we are going to learn what is work. So here we feel that this is how you people are all sitting and studying, isn't it, children? So you feel that you're doing a lot of work while you're doing with your studies. Okay, even me right now, when I'm going to when I'm recording or when I'm doing some teaching online, so here even what do I feel? I feel that I am working. Okay, but does this all mean work? No, these are all not work. That is what we are going to learn in today's video. Okay, so today we learn how these are all not called work. If these are all not called work, then what is work actually called? So we all need food to live, isn't it, children? So in order to have food, we do a lot of activities to survive. So that is what we were calling as work. But all these activities are various life processes. So whatever we need, we do. Everything doesn't mean work. Okay, so everything cannot mean work. So how do you define work? So work is done when a force causes an object to move in the same direction that the force is applied. Okay, that means there is a force which causes an object to move. Is it clear, children? There is a force which causes an object to move. So the mandatory thing is that the object must move. Okay, and there should also be a force, isn't it? So we need a force and the object should also move. So both of these should be present. Only then we call it to be work. So work is said to be done if a force displaces an object from its position. So we need a force and we need the object to be displaced. So we can define work, or we can write the formula of work as force into displacement. So this is the formula of work, and we can write it as F into S. Is it clear, children? So this is the formula for work. So we can write W is what? F into S. So what is F? You have already learned that F is equal to what? M into A. So what is the unit of force? It is going to be kilogram, and for acceleration is what? Meter per second square. Okay, so your force is what? Kilogram meter per second square. Okay, and then you have another S. So what is this S? This S is the displacement. And what is the unit of displacement? It is going to be meter. The unit can become kilogram meter square per second square. So you can write it as kilogram meter square s to the power minus 2. So this is how you can derive the unit of work from the formulae. You should learn this, children, because when you go to higher classes, you should learn to derive the units from the basic units. Okay, so the SI unit of work is what? Joule, or it is going to be kilogram meter per second, meter square per second square. So what is the SI unit? Basically it is going to be joule. Okay, it is going to be joule, and which is named after the scientist. So work, when you are going to see this example, you can see that work is done against the gravity while climbing the stairs. Okay, so when this person is going to climb the stairs, you know that the gravitational force is always acting downwards, but he is moving against the gravitational force. So in that way you can say that it is going to be done against the gravity, against the gravity. Okay, so you say that you work in science when you exert a force that causes the object to move. Okay, both should happen. If either of these are not there, that means we have F into S. If F is not there, what will happen? It will become 0. So then what will happen? 0 into S will become 0. Likewise, if there is no displacement, it will become F into 0, which is also going to be 0. So either of these should never happen. We need to have both the parameters. So if the object does not move, no work is done, no matter how much force is exerted. For example, if you are going to push a heavy object, so here you can see some heavy object. The person is trying to push and it doesn't move at all. But still, though this person has exerted some kind of energy, but just because it has not moved, you can say S is going to be 0. If S is going to be 0, work is also going to be 0. So this is how you are going to define work. So work is what? It is going to be a scalar quantity. Remember children, work is a scalar quantity. Work can be positive, 0 or negative. Why? How all these are going to happen? All these we are going to discuss in the part 2. Okay. So 0 you will say, you already discussed. Positive we know when both are going to be the same direction. Negative, it is going to be the opposite. We'll look at it very much in detail. So wherein the second part, when you will be able to understand this. Okay. So just because you say it is negative work, you cannot say it is going to be vector. Okay. It is going to be negative because it is going to be another work done by the frictional force. Okay. So wherein you are not calling it to be a vector quantity. Just don't think that since the answer is negative, it can be vector. No, it cannot be vector. Here it is going to be a scalar quantity. The SI unit of work is what? Joule. And what is 1 joule? 1 Newton into 1 meter. What is 1 Newton? F. F into S. S is in terms of meter. So you can also say the unit to be Newton meter. Okay. And another important definition which you need to learn is about 1 joule. 1 joule is the amount of work done when 1 Newton of force acting on a body displaces it through 1 meter. Okay. So 1 Newton is going to act to displace that particular object through 1 meter. Then you call the work done to be 1 joule. Is it clear children? So this is how you are defining work. Okay. So in physics, the term work is referred to the amount related to an applied force that moves an object to a certain distance. Okay. And work is not a form of energy, but work is a way wherein we can transfer or transform energy. Is it clear children? So this is how we are defining work in the first part. Okay. So we are going to learn a lot more about this chapter in the upcoming videos. Please stay tuned for all these children. We'll do every concept one by one, part by part. Please go through the videos which I have posted already for the first 2 chapters in physics also. So see you again with another video with the second part. Thank you children.